The Gotthard Massif. For centuries it has been a natural barrier between northern and southern Europe, but not for much longer. In future, the journey from the north to the south side of the Alps will take just 2 hours and 40 minutes. The Gotthard base tunnel is part of the new Alpentransversale railway, which will cut a whole hour off the journey time from Zurich to Milan. For trains with speeds of up to 250 km an hour, the construction work requires absolute precision. Engineers and fitters have to install overhead contact lines into the 57-km-long single-track tunnel tubes. The concrete tunnel vault provides a secure area for fixing. The powerful forces created during high-speed operation are absorbed by these reinforcements. All 40,000 fixings are individually tested for 3 minutes each, and each has to withstand a force of around 7 kilonewtons. To ensure that the fitters in the tunnel can work safely and as ergonomically as possible, the engineers from Balfour Beatty and Kummler+Matter designed the so-called construction train to transport the men and their tools to the worksite. One example is earthing operations. Here, the low platform of the construction train makes the work safe and efficient because it can be reached from the platform. Engineers and specialists are developing special supporting structures for the Gotthard base tunnel. In the lab, the prototypes of the suspension hangars undergo corrosion tests and X-ray examinations until they are optimized and the Federal Transport Office has approved installation. Installing two 57-km-long overhead contact lines in tunnel tubes which are only single track is an operation that demands a great deal of expertise, plus perfect logistics at the installation site. All components are pre-assembled as far as possible. The buildings and halls contain automated workstations, the logistics center, and the materials store. Every component needed for installation in the tunnel, however large or small, passes through here. Altogether, the fitters drill over 40,000 holes for the fixings, mount thousands of supports, and travel tens of thousands of kilometers to and from the installation site, using the construction train specially designed by Balfour Beatty and Kummler+Matter. The forklift truck on the train is secured against slippage and has a special mechanism for reaching the components without shunting and transferring them to the fitters on the platform with great precision. High-powered magnets bear the weight of the 150-kilo suspension hangers until they're securely fixed. The preparations for the years of work in the world's longest rail tunnel are the exclusive task of specialists. The development teams in Zurich accompany and supervise the project. This is where engineering expertise for a once-in-a-lifetime project originates. One globally unique solution is the construction train. The self-propelled wagon has an electromechanical drive, which can reach every working position with great accuracy. The units travel in a convoy along the routes to the site at a speed of 80 km an hour. Depending on the task, the train has several different formations, thus saving on valuable assembly time. The teams have to maintain safety distances and install all the components within the tightest of spaces. That includes the so-called radio or leak cable, an intentionally leaky cable that has the properties of an antenna and transmits radio signals to the train. The planning for installation of the overhead contact lines has been underway since 2008. Placed end-to-end, all the documents would cover 3 football fields. The detailed design makes installation in the tunnel far easier and more efficient. The sustainable construction has a service life of over 40 years and has to fulfill ultra-stringent safety requirements. For example, the distance from the contact lines to the tunnel roof must never be less than 25 centimeters. The solution are these brackets, screwed onto the suspension hangers. Here, insulators with a fiberglass reinforced core and silicone lamellae ensure that no flashovers occur. The assembly teams are making good progress because nearly every trip and every move was simulated in the planning beforehand. In regular operation at 250 km per hour, the height of the contact wire must never deviate from its precise distance of 5 meters 20. This is why the catenary system is tensioned with weights. The highest demands are also placed on the quality of all components used. Lab tests ensure that they fulfill all requirements in terms of conductivity and stability. The contact wire and the catenary wire are now ready for installation. The fitters will be using a total of 1,400 tons of copper. New safety concepts, safe design and safe construction processes all support them here, and every man returns safe and sound from the tunnel every evening. This is also made possible by the technical equipment on the construction train, which this morning is entering the tunnel in its longest and most elaborate formation yet. To allow several locomotives to use the 57 kilometers, 4 line feeders supply the contact wire with the necessary power. Even though the assembly work seems rough, the contact wire has to be finally positioned with absolute precision. The contact wire is now hanging in position, and so is the catenary wire. This is the crucial moment. The line is slackened and the weights do their work. The fitters and engineers know they can rely on everyone else in their teams. Planning and implementation are rolled into one.
Wir müssen im Prinzip nachweisen, dass die Test and Commissioning demonstrates that all technical and project requirements are working as developed during the concept and design stages. It ensures that interfaces between different and existing systems, as well as third-party systems, are integrated and systematically closed. The testing and commissioning phase is very important. This series of activities is necessary in the construction of a high-speed railway system before it can be safely opened for the commercial operation in the year 2016.